Most tanks are built around one key idea: a rotating turret. Strv 103 rejected it completely. Instead of turning a gun, it aimed by moving the entire tank. Low, compact, and heavily armored, it was designed for a very specific kind of war, defending Sweden against invasion. On paper, it offered serious advantages, but it also raised a fundamental question. Can a tank without a turret really compete on the battlefield? So why did Sweden build one of the most unconventional tanks ever made? And did the idea actually work? By the interwar period, tank design had largely settled into a form that would define armored vehicles for decades. A rotating turret mounted on a tracked chassis became the standard solution, allowing the tank to combine mobility, protection, and all-around firepower in a single platform. This configuration proved flexible and effective, and by the time of World War II, it had become the dominant design used by nearly all major powers. At the same time, however, another class of armored vehicles continued to develop along a different path. Self-propelled guns and assault guns often abandoned the turret entirely, mounting their main weapon directly in the hull. Vehicles like the Stug 3 demonstrated that a turret was not always necessary, especially when the primary role was direct fire support or defensive combat. These vehicles were simpler, lower in profile, and easier to produce, while still delivering effective firepower. Combat experience led to further analysis of tank survivability. One important observation was that a large proportion of destroyed tanks were hit in the turret. This was not accidental, as the turret was often the most visible and exposed part of the vehicle, and in many cases the most critical. At the same time, overall height became a key factor. A taller tank was easier to detect, easier to target, and therefore more vulnerable on the battlefield. These observations raised a fundamental question: was the turret truly necessary? For Sweden, this question was not theoretical. During the early years of the Cold War, the country faced a very specific strategic problem. Sweden maintained a policy of neutrality, but at the same time needed to prepare for the possibility of defending its territory against a major power. This required a capable and modern armored force. However, acquiring such equipment was not straightforward. Foreign suppliers were often unwilling or unable to provide the types of tanks Sweden required, especially in the quantities and configurations needed for national defense. Political considerations, export restrictions, and strategic priorities of larger powers made reliance on imports uncertain. As a result, Sweden chose a different path and decided to develop its own tank. The responsibility for defining the requirements fell to the Royal Swedish Army Material Administration's Ordnance Department. Their analysis reflected both the lessons of past wars and the specific conditions of Swedish terrain and strategy. The new vehicle was expected to have an extremely low silhouette to reduce visibility and increase survivability, strong frontal armor optimized for defensive engagements, high mobility including the ability to operate effectively in varied terrain, low mass, and a powerful main gun capable of engaging enemy armor at range. At the same time, the design needed to be efficient, reliable, and suitable for Sweden's industrial capabilities. Within this framework, a radical idea began to take shape. If the turret was one of the main vulnerabilities of a tank, it could be removed entirely. This concept was developed further under the direction of Sven Berge, who became the key figure behind the project. His approach challenged the conventional assumptions of tank design. Instead of rotating the gun independently, the entire vehicle would be used to aim the weapon, using a combination of track movement and adjustable suspension. This idea was unconventional, but it directly addressed the problems identified earlier. By eliminating the turret, the tank could be made significantly lower, making it a harder target to detect and hit. At the same time, the design allowed for strong frontal protection and efficient use of internal space. What began as a response to practical limitations, strategic, industrial, and tactical, was quickly turning into one of the most unique tank concepts ever developed, eventually leading to the creation of the Strv 103. The main idea of aiming a tank's main gun without a turret was not entirely new. Earlier designs had already experimented with this approach, most notably the French Char B1. In that vehicle, the main hull-mounted gun was aimed horizontally by turning the entire tank, while vertical aiming was handled through limited elevation of the gun itself. This system worked in principle, but in practice it placed a heavy burden on the driver, who had to act not only as a vehicle operator, but also as part of the gun-laying system. Coordination between crew members was difficult, and accuracy, especially against moving targets, was limited. Similar concepts appeared in other early tanks and assault guns, where the absence of a turret simplified construction but reduced flexibility. In most cases, these vehicles compensated by accepting narrower firing arcs and focusing on specific roles, such as ambush or defensive fire. However, they still relied on relatively conventional methods of gun control, with limited precision compared to turreted designs. The Stridsvagn 103 took this idea much further and turned it into a complete system rather than a compromise. In the Strv 103, the gun was fixed rigidly in the hull with no traditional elevation or traverse mechanisms at all. Instead, the entire vehicle became the aiming platform. Horizontal aiming was achieved by turning the tank using its tracks, much like in earlier designs. However, what made the Strv 103 unique was its method of vertical aiming. The tank was equipped with a hydropneumatic suspension system that could raise or lower the front and rear of the hull. By adjusting the angle of the chassis, the crew could precisely control the elevation of the gun. This allowed for surprisingly fine adjustments, far beyond what earlier hull-mounted systems could achieve. In effect, aiming the gun required coordinated control of both movement and suspension. The driver handled horizontal alignment, while the suspension system controlled vertical positioning. Unlike earlier tanks, this process was not purely manual. The Strv 103 incorporated advanced fire control systems for its time, including stabilization and range-finding equipment, which allowed the crew to aim with a level of precision that compensated for the lack of a turret. This created a very different firing process compared to conventional tanks. Instead of rotating a turret and adjusting a gun independently, the entire vehicle had to be aligned with the target. This might seem like a disadvantage, but it also introduced certain advantages. Because the gun was fixed, the structure around it could be stronger and more stable. This improved accuracy, especially when firing from a prepared position. The absence of a turret also allowed for a much lower profile, making the tank harder to detect and hit. Another important aspect of the Stridsvagn 103 was its crew and internal layout, which directly reflected Sweden's strategic realities. Unlike larger powers, Sweden did not have a large population or the ability to maintain massive armored formations. This made manpower efficiency a critical factor in vehicle design. The Strv 103 addressed this by reducing the crew to just 3 men, compared to the 4 typically required in conventional tanks. This was made possible through a high degree of automation and an unusual distribution of roles. The tank was equipped with an autoloader, eliminating the need for a dedicated loader, while both the driver and the commander were capable of controlling the vehicle and operating the gun. In fact, the tank had duplicate driving controls, one facing forward and one facing backward, allowing it to be driven efficiently in both directions without turning around. To understand how the Stridsvagn 103 would perform in combat, it is necessary to look not only at its design, but at the environment and doctrine it was created for. This was not a universal main battle tank in the same sense as vehicles developed by larger powers. It was a highly specialized system built for a very specific kind of war. Sweden, during the Cold War, expected a defensive conflict on its own territory. The terrain was not open plains, but forests, rocky ground, lakes, and narrow roads. Visibility was often limited, movement constrained, and prepared defensive positions could be carefully selected in advance. Under these conditions, the ability to remain hidden, survive the first hit, and deliver accurate fire from cover was more important than aggressive maneuvering. The Strv 103 fits this environment almost perfectly. Its extremely low silhouette makes it difficult to detect, especially in forested or broken terrain. When positioned in a hull-down or partially concealed position, only a minimal part of the vehicle is exposed. Combined with strong frontal armor, this significantly increases survivability in defensive engagements. The fixed gun, often seen as a limitation, becomes an advantage here. The vehicle is already aligned toward expected avenues of approach, and only small corrections are needed to engage targets. In such a scenario, the Strv 103 functions less like a traditional tank and more like a mobile, armored firing position. Its ability to reverse at high speed without turning around allows it to engage, withdraw behind cover, and reposition quickly. When combined with prepared positions, camouflage, and coordination with infantry and anti-tank units, it becomes part of a layered defensive system rather than an isolated fighting vehicle. In this context, its limitations are minimized. The need to aim the entire hull is less of a problem when targets are expected from known directions. The difficulty of firing on the move is less critical when engagements are planned from static or semi-static positions. Instead of reacting to a rapidly changing battlefield, the Strv 103 shapes the engagement on its own terms. However, these advantages are closely tied to environment and doctrine. In a more fluid battlefield, such as the open terrain of Central Europe or desert regions like Iraq, the situation changes significantly. Tanks like the M1 Abrams or T-90 are designed for maneuver warfare. They rely on mobility, turreted fire control, and the ability to engage targets quickly from multiple directions while moving. In such conditions, the Strv 103 faces clear disadvantages. The absence of a turret means that engaging multiple targets in different directions requires repositioning the entire vehicle. This takes time and space, both of which may be limited in a fast-moving engagement. Tracking moving targets, especially at close range or from unexpected angles, becomes more difficult compared to turreted tanks, which can simply rotate the gun independently of the hull. Firing on the move, a key capability in modern armored warfare, is also more challenging. While the Strv 103 has advanced suspension and control systems, stabilizing the entire vehicle is inherently more complex than stabilizing a turret-mounted gun. In dynamic engagements, this reduces reaction speed. In open terrain, its low profile still offers some advantage, but concealment is less effective without natural cover. Detection ranges increase, and long-range engagements favor tanks with advanced optics, fire control systems, and the ability to quickly engage multiple targets. If we imagine a hypothetical encounter between a Strv 103 and modern tanks like the M1 Abrams or T-90, the outcome would depend heavily on context. In an open battlefield, with both sides maneuvering and supported by reconnaissance, drones, and air assets, the Strv 103 would likely be at a disadvantage. Its slower target acquisition in dynamic situations and limited flexibility in close or multi-directional engagements would make it harder to compete against turreted tanks designed for exactly these conditions. However, in Scandinavian terrain, the situation could be very different. In forests, narrow valleys, and prepared defensive lines, the Strv 103 could use its strengths fully. Concealment, ambush tactics, and coordinated defense would reduce the advantages of more modern tanks. Engagements would occur at controlled angles, often from concealed positions, where the Strv 103's low profile and strong frontal armor would be most effective. In such an environment, the difference between vehicles becomes less about absolute capability and more about positioning, coordination, and tactical execution. This highlights the most important point. The Stridsvagn 103 was not designed to be universally superior. It was designed to be optimal within a specific system: Swedish defensive doctrine, terrain, and operational planning. Compared to traditional tanks, it sacrifices flexibility for specialization. In offensive operations, rapid advances, and unpredictable engagements, this specialization becomes a limitation. But in a defensive war, fought on prepared ground and supported by integrated forces, it can become a significant advantage. In other words, the effectiveness of the Strv 103 is not defined only by its design. It is defined by where and how it fights.